Organizing committee of this workshop. I'd like to welcome everyone to our workshop, Human Factors, Engineering, Improving Production Quality and Minimizing Workplace Injury Risk. We have a full day planned for you, and I hope by the end of the day you will have a clearer understanding of what human factors and ergonomics can offer to industry. Before we start our program, let me introduce the director of the CRE-MSD, Dr. Richard Wells. Please.
Thank you, Amit. Just repeat the welcome. And you might ask why CRE-MSD, which is a center, distributed center, a network of researchers looking to prevent MSDs, is talking about quality. And I think the reason is that ergonomics or human factors, we're going to use the same words as equivalent, is good for workplaces, is good for health, for performance. And so we want to make that link and convince you, if you're not convinced already, that human factors is a good thing to consider in the design and operation of production systems. And so with that as an introduction, what I'd like to do is just have a few administrative comments here. One of the first ones is I'd like to acknowledge our collaborators in putting on this conference, which is Auto 21 and Options Incorporated. I'd also like to bring your attention to a page that looks something like that. That should be on your table. And the point of these questions, which is, how can we take current knowledge about human factors and quality and make it useful for industry? So what information is out there that we can already use? And the second question is, what are we missing? And how can we, as researchers, as collaborators from industry, move ahead that knowledge so we can do better? And so as we move through the day, please keep those two messages in mind and bring those forwards for the discussion at the end. We will be handing around some cards, and if you could jot down questions as we move forwards, we can bring those back at the end of the day. Some even more administrative comments would be that we have exits at the back and here. The washrooms are right outside the door, very conveniently, and lunch will be down on the second floor. Just a quick look at our agenda to give you a sense of how we're planning the day. As you can see, we're in the introductions, and I'll be introducing Dr. Patrick Neumann soon. We have Dr. Colin Drury, who's going to introduce the concept for us, and then we're going to move into a series of presentations that lay out the big picture about human factors and quality. And we'll move from the large to the more specific as we move through the day. And at the end of the day, it's not what it's supposed to do. We want to come back and take the questions that you have on your table and relate that to the materials we've had today. So again, keep those two questions in mind on the cards. Please write the questions that we can use to seed the panel discussion if everyone suddenly becomes shy at the end of the day. And I wish you a very pleasant and informative day. And I'd like to introduce Dr. Patrick Neumann from Mechanical and Industrial Engineering here at Ryerson, who is one of our co-organizers. Patrick.
Thanks, Richard. I just want to spend a couple minutes a couple minutes positioning ergonomics and human factors a little bit, because I think we're operating frequently under a false assumption around ergonomics being strictly a health and safety issue. If we look at the definition of ergonomics and human factors, and you drill into it, I won't bore you with the full text, but there's two main objectives, right? Human well-being and system performance. And I think particularly here in Canada and some of the EU countries, we've really focused on number one a lot, and not really focused or understood so much how attention to the human and the system affects the performance. And the second piece, I think, is that human factor supports the design of new systems, of good systems. And if the system that you design doesn't fit the people that are working it, you're going to have a problem. I want to start just briefly tackling this issue of safety versus competitiveness. I know it's dangerous showing a little bit of data this early in the morning. What you have here is countries across the bottom, and they're in rank order of competitiveness. Don't ask me how they make these indexes, okay? But this is a competitiveness rank done presumably by someone like The Economist who knows what they're doing. And with the triangles, you have fatalities, fatal injuries per 100,000 workers. And you see quite clearly that the more competitive countries are the ones that have the lowest fatality rates. This is very macro data now, right? So here, Switzerland, Singapore, Finland, Sweden, Netherlands, Germany, UK. United States is in there as well, okay? Very competitive, very safe. Okay? Down on the bottom here, South Africa, Mexico, India, Hungary, Russia, Zimbabwe. Right? Lowest competitiveness, highest fatality rates. So you can start to wonder, well, what's going on? Right? What's going on? When we design our systems, we need to remember that we've got two kinds of effects, always. Okay? Work has two effects. It has what I call a system effect, and that's your quality, your productivity, your efficiency. Right? And you have an effect on the operators. And that could be a good thing, or it could be a bad thing. You could have an increase in skill. You could have an increase in fatigue. You could have the development of pain. Right? Whatever's happening, it's affecting your operator somehow. In terms of system effects, your productivity, your quality, your flexibility. And the point that people forget quite often is that whatever's affecting the operator is affecting your production, because the operator's inside your production system. So that if you're increasing skills, you're going to have a more competent operator, and you're going to get better system effects. If you're generating pain and fatigue, you can wonder how the performance is going to be in terms of doing the assembly tasks. Okay? This is where we're going to be drilling into today. What's happening? What's the relationship between the effects on the operator and the effects on the system? When I became interested in this issue with Jan Duhl, we did a systematic review. And we went looking for papers that had studied both human effects and system effects. So on the occupational health and safety side, there's like a gazillion papers, that's a technical term, a gazillion papers, right, looking at safety issues, but ignoring productivity. And then you look at the engineering literature, and you have a bazillion papers looking at efficiency and quality, but totally ignoring the human. We were able to find around 36 papers at the intersection point between those two worlds where people had actually studied both within the same research project. And while we saw a lot of improvements with the application of human factors in health attitudes, physical workload, this kind of thing, we also saw a lot of system effects, improvements in productivity, in quality, in the implementation of new programs and new technology, as well as these intangibles where people had problems putting a dollar figure on it, but how valuable is increased communication to you? How valuable is better coordination between groups? Okay, these are things to think about. When we look at at the covariance of them, so we had human effects here, they either got worse or better. System effects either got worse or better. Of the 38 studies we were able to include, 95% of them had productivity, had system effects and human effects go in the same direction. They either both got better on 33 studies, or there was a few where they both got worse. Okay. There was only 2 studies we found that had conflicting effects, where human effects and system effects went in the opposite direction. So this was intriguing to us. 95% of the time, the performance and the human well-being go hand in hand. And of those, the quality was one of the ones of particular interest, and this is what we're going to be focusing in on today. Now, most of the time, if we think about what's happening with human factors knowledge, we have the operator effects, maybe we have MSD problems, the Occupational Health and Safety Service kicks in, and they start focusing on the person. Right? So we have this little loop here. But what's happening to design? Right? This has been called the sidecar of ergonomics. Here's our ergonomics, our ergonomics knowledge. I'm hesitating to say ergonomist. I'm a professional ergonomist, so I can say these things, right? In the sidecar, right, they don't have any control. They can't steer. They can't put brakes on. They can't gas, right? All they can do is complain to the driver, right, who's the production operator. So this sidecar problem really isolates our human factors knowledge. And you can start to ask, when you look at how knowledge is being done, yeah, okay, you can start to actually be more active in the sidecar. But are we able to tap in to our design processes here? Right? Product design, process design, those are the things that are defining the production system. And then here we have HR with their little loop. Right? If we want good performance, we're going to have to start dealing with these design processes. And if you want good quality, you're going to have to start dealing with it up front. And that, I think, is one of the aims of the day, is to talk about what are these relationships between what's in a production system and the eventual quality effects. And how can we deal with these in design? How can we get into these design processes so the knowledge is applied? So human factors is not a goal. Ergonomics should never be your goal. Ergonomics is your means. That's how you get there. Safety is a goal. Productivity is a goal. Quality is a goal. Human factors is a method. It's a means of achieving that. So that your sickness and absence gains are the tip of the iceberg. But your performance gains at, again, 9-to-1, 10-to-1 ratios are everything that's underneath your compensation claims. This is where the big gains are in ergonomics, and because it's often hidden, it's often hard to build in. Why not do it later? Well, this is a classic design science image. As you move through the design process from requirements to actual manufacturing, your ease of change drops. Right? By the time you're into the concept, you've already decided what your equipment is, maybe you've placed orders. It becomes very, very hard to make changes. But if as an ergonomist and as an engineer, you can build these issues in at the requirements and concept stage, you're way out in front. Okay? Then you have a chance of dealing with or achieving the kind of synergies that we're seeing in the literature, but that seems so rare when we look at production systems today. So I want to welcome you all to this workshop. We have an amazing set of speakers. I'm really excited about hearing their talks. I'll just draw your attention one more time to the questions for participants. All right, this is what we want to be thinking about today. How are we going to be applying or using the knowledge? And if there's gaps, if there's things we need to do, how are we going to work together moving forwards to try to achieve that? So participate, do ask questions. There'll be lots of opportunities for discussions. We hope you learn. I'm sure I'm going to learn. And I also hope you enjoy the show.